So Taco Tex Bex was like, "This project's on fire," and I'm like, "Oh, well, let's put it out then." And I kind of whipped this up in like a second. So there you go. There's some rain. That height map I implemented actually came in handy. It makes this actually a lot faster than I thought it was going to be. I limit it to 8 within your positional distance. You know what, let's change that right now, actually. Let's do this. Let's go to the player, and position.y, and we'll do get camera, get player position with eye height dot y. Whoops, data debug mode. Oh my god. Oh, it actually still runs correctly. Okay. Okay, so the same efficiency. Only now it has your eye height. That's cool. And let's make it even more efficient. Let's have a float eye height y equals so we don't have to call that every time because that's doing an adder. So let's make that a float. Is less than or equal to, and then math.random. It's amazing. Okay, that's a little bit better actually. So these are the benefits of the point-based collision detection, where I can do ridiculous stuff like this that is completely unoptimized, but it worked. I didn't think this was gonna work. That's why I'm making this video. I just wanted to show you guys that stuff like this was possible even without optimizations. It works underground too. Also, that thing that I showed in the video where I was saying how I could make the particles stand straight up and why that was such a big benefit, and this is one of the reasons basically. Maybe I'll implement snow later, and we'll see how that goes. I don't know how that's going to go, but we'll see. Okay, so that height map that I'm talking about, you can see how this actually implements itself. Also, these particles will delete when they hit the ground, which is really cool. I can do a particle effect on the ground as well. But we'll see about that. You could probably see that it's raining down in here. But since the height map is implemented as the standardization point for the bottom of the column that is being generated, it will not rain inside of your house automatically. I still got to fix that lighting issue, but I thought I'd just implement this because this is kind of fun. Amazing. Let's go build a house on the top of this. Yeah, we'll just kind of build it here. Let's see, let's build it out of, not sure. Not TNT this time. That was a little too cliche. Cobblestone, there we go. Getting unlucky with these inventory randomizers. Oh, I got 60 again. What are the chances of that? So that lighting definitely needs to be improved. I'm not sure how I'm going to do that. This is my little break I'm taking from the lighting, because the lighting is very difficult. So this is so cool. So you're going to see, as I do this, it doesn't rain under me automatically. I mean, I don't know what I just said. I think I said it doesn't rain under me automatically. It doesn't rain in the house automatically. I was so dumbfounded by the fact that this actually worked and I whipped this up in like 10 seconds that I'm just like, I'm genuinely confused. And it's going to get real dark in here. So, oh yeah, we have to implement the two-stage system because the y-axis isn't accompanied for. We'll just put it right here. Now that is pretty dang cozy. So something I always had a problem with in the Minetest engine is there's no actually definitive way to get if something would be underneath sunlight all the way from the column of the top of the world, because the world's 31,000 high from the Y height. We'll just assume that the Y height of the generation of land is always 0. I don't know why we're doing that, but we're going to do that for this example. But the problem is there's no definitive way to get the actual position if you're under the clouds, basically. I'm sure there's some very complex math you can do to do that, but there was no way that I could figure out simply from the Lua VM. But since the column of these chunks only go to 127 for now, I can easily utilize the height map and basically just improve everything I implemented into Crafter in the Minetest engine into the base engine of this, basically. So now, even with this horrible, inefficient rain, it actually it works. This is crazy. I'm thinking about implementing snow. Trier's algorithm actually converts the area for, I'm talking about the weather, the snow placing algorithm in Trier's implementation in the weather mod that I did in the Minetest engine. And what Trier's algorithm was actually doing was it's called Fizzle Fade, because it does a bunch of square rooting and whatnot. Do not quote me on that, because even I barely understand how he figured that out, which I'm just genuinely impressed by that. But what I can do is try to translate his code into Java and basically make it happen in the world. And what I can do with that is basically make it so snow spawns like it does in Crafter, only make it so it doesn't need all of that CPU enforcement, like the super brute force of the CPU to implement calculating basically the area of where snow would be placed, because you already have the height map automatically whenever the terrain is modified when it's generated, when it's modified, and it is always locked into memory, and there's no way to actually cause it to get corrupted, essentially. Like, it won't, if we place something here, it won't just say that something's down there, because it is actually a lock implementation that the height map will always get modified per terrain modification, even if you do this. I've learned from my mistakes, and we're gonna do this. Okay, so you can see it still rains in here, which is very nice. Let's go seek some shelter real quick, and it's not gonna rain in here. Even with set block, the terrain height map is perpetually modified. Since that is byte data, since this is a 127 height, it actually works out extremely well, because it's a very small amount of memory to pass through from the CPU to the memory of the system, and vice versa, which makes it ridiculously fast, because it doesn't have to hold more bits of data in the pipeline, basically, or whatever it's called, whatever the line is from the CPU to the CPU cache to back to the CPU, back to the RAM. It's less data to streamline, or stream, whatever it's called. Let's see. So if we blow the house up, you can see that the rain still spawns in here because the height map is perpetually modified, which is very nice. So let's go get some shelter. Like so. And ta-da! Well, guys, that's all I got for the rain. Not much more I could explain about it. It's just rain that's using point collision detection, and it's using a bunch of particles, which is extremely inefficient. What I can definitely do is I can have a basically I can have the man, I don't even know how to explain this. I can have the camera look at something, like, let's just say this is a blank mask right here. So let's say there's a rain particle. Whoops. There's a rain particle here. What I can do is crisscross that mask, or mask column, per height map, and I can make it look like this, but better. But it's going to be extremely difficult to do that. It's going to take a lot of rendering tricks to do that, and we'll see how that goes. So anyways, guys, I'll see you in the next video, and peace out.